Yes.
She's gonna have to go in a different room. So baby Tay is squealing and I can't hear anything. Okay, so all we're gonna do is, besides testing out this system here, we're going to solve a system with 3 equations, and we're gonna solve it using substitution and addition only. We're not gonna solve them by graphing, and it's not because graphing isn't good. It's because you have to have special graph paper to graph something that has 3 variables. The graph paper looks really cool, but we're not gonna mess with it. We're just gonna do substitution and addition. So hopefully kind of painless if you were okay with substitution. Feel okay about that? Yes? No? Maybe?
Yeah.
That is not the kind of commitment I have come to expect from this class. So if something comes up while we're in the middle of class and you got to step away, that is completely fine. I understand that life happens and you got to take care of the kids or whatever. So when class is over, hopefully this Zoom software is supposed to record this. So hopefully when it's all done, I will have a really nice recording that I can put on YouTube so you can watch it again later.
Oh.
So this is what a system in 3 equations looks like. And you will notice that it's got 3 variables in it, x, y, and z. So the methods that you learned last week aren't really going to work here because you definitely can't graph it with an x, y, and z in it. And you can maybe do elimination a little bit. You can kind of see maybe there's some addition right here. If we added the z's would go away. So maybe there's some potential there, but then we'd still be left with this right here, the 2z. So elimination is a little bit problematic. And substitution is also a little rough too. We're used to doing equations that only have 2 variables. Doing them with 3 is a little rough. So what we're going to do is we're going to pick just 2 of these equations. It doesn't matter which 2 you pick. I'm going to take just the top 2 just because. We're going to use just those top 2 equations. I'm going to go ahead and write them out separately over to the side. And the reason that I'm really liking those top 2 is for the reason that I just said. If we do the addition method, we could get rid of the z variable. So just a quick refresher, the way you do the addition method is that you just take these 2 equations and you add them straight down. So if I just add these 2, I get 3x plus x, which is 4x. And then I get negative y plus 2y, which is a positive y. And then the z's here are going to eliminate. The positive z and the negative z go away. So my new equation doesn't have any z's in it. That's good. And then it equals negative 14. Make sense so far?
Sounds good.
So far, so good? All right. So we've now taken 2 equations and we've adjusted them so that they only have 2 variables in them now. You'll notice the thing we just came up with only has an x and a y in it, which is really nice. So I want to do that again. I want to pick 2 different equations and I want to adjust those 2 equations so that they also only have an x and a y in them. So I'm looking at these 3 equations and I'm trying to decide which 2 I could put together really creatively to do elimination. And I really like the first one again and the last one. And the reason I really like the first one and the last one is because I noticed if I multiply this first one, if I multiply this first one by 3, I'll end up with this term right here being a minus 3y, which will eliminate with the plus 3y. That seems pretty good. So I like that one. I also like that if I multiply the top one by 2, that would give me a plus 2z, which would eliminate with the minus 2z. So I like the idea of doing those 2 equations for a couple of reasons. So let's go ahead and rewrite those 2. I'm going to do the top one and the bottom one. So the first pair of equations I did, when I used the elimination method, I got rid of the z variable, which left me with just x and y. I would like to do the same thing with these two equations. I would like to use the addition method to get rid of the z's so that I'm left with just x and y. So that's going to be my goal. How can I get rid of the z's? And we talked about it just a second ago. We said, hey, if you multiply the first one by 2, that will turn the plus z into plus 2z, which will eliminate with the minus 2z. So I'm going to multiply everything in this top equation by 2. That gives me 6x minus 2y plus 2z equals negative 30. Give you just a second to write that down because I did that kind of quick. I'm multiplying every single thing in the top equation by 2. And the reason I'm doing that is so I can eliminate the z's, so that I will have only x and y, just like I did in the first pair of equations I added. The second equation, I'm not going to do anything to that. I'm going to leave that one alone. And so if I add these two equations now, the z's will eliminate. And I'll be left with 8x plus negative 2 plus 3 is 1, so plus 1y. The z's are going to completely cancel. That was the whole idea, was to get the z's to cancel. And it will equal negative 30. So the two things that I've highlighted in green here, these two equations, are two equations that now only have two variables in them, just x and y, which is really handy because we know how to solve equations that only have two variables. We did that last week in class. So I'm going to take these two equations, the ones that are highlighted in green there, the 4x plus y equals negative 14, and the 8x plus y equals negative 3, and I'm going to work just with those two. So there's those two equations. And I've got really two pretty good options for eliminating a variable there. What are my two options? What could I do to eliminate a variable in those equations?
You could turn one of the y's negative.
Good. I could multiply everything by negative 1 in either the top or the bottom. What's another one I could do?
You could multiply the top one by 2, and it would get 8 on the x, but you would have to put it in negative.
Right, so I could multiply the top by negative 2. That's a great idea. I think I'm going to go with your first suggestion, which was to multiply by negative 1, just because multiplying by 1 is slightly easier than multiplying by 2. It doesn't matter whether you do the top one or the bottom one. I'm just going to go ahead and do the top one, just because. So if I multiply the top one by negative 1, I get negative 4x minus y equals positive 14. And the bottom is going to stay the same. 8x plus y equals negative 30. All right. And the reason that we did this is so when we use the addition method, the y's go away. Negative 4x plus 8x is 4x. The y's are going to completely eliminate, which is nice. And then on the end, I have 14 equals negative 30. That's going to give me a negative 16. I am one step away from knowing the value of x. What's the one step?
Dividing by
Divide by 4.
That's exactly right, dividing by 4. Well done. So I end up with x equals -4. Oh my goodness, that is not a good color combination. Oof.
Yeah.
Okay, note to self, highlighting yellow with red, bad idea. So there we go, I got x equals 4. So after doing all that work, I am 1/3 of the way finished with this problem. I need to find the values of x, y, and z, and now I have x. So that was a lot of work to find x, but the good news is now that you have x, everything else is kind of easy to find. I think the easiest thing to find next actually is going to be y. And the reason that I think y is going to be the easiest thing to find next is because I could just come up to this equation right here, for example, and plug in, substitute the -4 for x, and then solve for y. That would tell me what y is in like basically 2 steps, right? So let's do that. Let's take the 8x plus y equals -30. And let's substitute the x with the -4. So we'll do 8, and instead of x, we'll do -4 plus y equals -30. And that doesn't seem bad at all. I'm really just a couple of steps away from knowing the value of y. What should I do first in this problem?
Multiply 8 by -4.
Yeah, great. I should do the 8 times the -4. Good idea. So -32 plus y equals -30. And then,
Then you would plus 32 to the -30.
great job. Add 32 on both sides. So now I know the value of y is 2. That's handy. So I know the value of x, and I know the value of y. All that's left for me to do is find the value of z. And I can find the value of z using any of my previous equations that have the variable z in them. Now, since my first 2 steps were to eliminate z, for me to find an equation with z, I got to go all the way back up to the original problem. And I can use any of those 3. Any of those 3 equations will work. I really like this one. I like the middle one because the coefficients are so small. It's like a 1x and a 2y and a -1z. That seems really easy. So I'm going to do x plus 2y minus z equals 1. That one just seems like the easiest equation just because the numbers are the smallest. I could have used any of those 3 and it would have been fine. So now that I have that done, I'm going to replace the x with 4. Sorry, -4. And I'm going to replace the y with 2. And then I'm going to solve for z. So I'll have -4 plus 2 times y. Y in this case was 2. Minus z equals 1. Okay, so 2 times 2 is 4. So I'm going to do -4 plus 4 minus z equals 1. Remember, you are allowed to use a calculator. So -4 plus 4 is... You don't have to whisper it, it's 0. But be careful. It's 0, but it's 0 minus z. So don't forget the minus sign in front of the z. Don't suddenly make that a positive z. The -4 and the +4 go away, but the minus in front of the z doesn't. So I'm left with -z equals 1. So if -z equals 1, then +z equals... This is audience participation time.
-1.
Very good, -1, fantastic. So the answer to my problem then is x equals -4, y equals +2, and z equals -1. And if you want to write it the way the pros do, we can still do x, comma, y, comma, z. Either one of those answers are perfectly acceptable. I kind of like this one a little bit better because that's how you would write the coordinates. And seriously, if you haven't looked at three-dimensional graph paper, it's super cool. You can actually graph an x, y, and z equation. We won't use it in this class at all, but it just looks cool. You can Google 3D graph paper if you get bored or have some insomnia or whatever. 3D graph paper. It looks really cool. All right, what do you think? So far, so good?
Mm-hmm.
Yeah. Any questions on the first problem? This would be a great time to ask. You're almost completely anonymous. No? Everybody feels okay about that? It's a little overwhelming, right? Because there's so many steps. But what I want you to notice is that all of the steps were to find the first variable, x. Once you found x, the dominoes kind of all fell and we were done with the problem. So getting the first variable is the tricky part. Once you get the first variable, you're good to go. All right, so let me give you another one. This one's going to have a little trick to it, of course. So our first equation is 2x minus 4y plus 8z equals 2. Our second equation is -x minus 3y plus z equals 11. And our third equation is x minus 2y plus 4z equals 0. So our last problem that we did, the very first thing that we tried to do was to eliminate one of the variables. So if you look at those three equations, are there two equations you see that when you put them together would help you eliminate one of the variables?
The second and third equation.
Yeah, I love the second and third. Why do you think those are good ones?
Because one x is negative and the other is positive.
That's exactly right. So if I were just to add those two like they are right now, the x's are gone and I'm left with y and z, which is great. So let's do that first. Excellent idea. So we're going to take those two equations, and if I just add them right now, one of the variables goes away. What I want you to take away from this problem is that we don't have to be left with just x and y. I know we really like x and y because that's how most of our equations have been written up to this point, but we just need any two variables. There's nothing special about x and y. It can be y and z. Now we have to stop right there. We can't do any more with this equation because it still has two variables in it. Not a lot we can do with two variables. So we're going to have to go back to our original problem and see if there's a way we can eliminate x from two other equations. I can only see video from Carmen, so whenever Carmen looks at the screen, I assume everybody is done writing.
Yeah.
All right. If I'm going too fast, let me know. The only one I can see that's ready to go is Carmen. So everybody else, you're just going to have to let me know if I'm going too quick. All right. So look at those three equations that are left. My goal is to eliminate x so that all I'm left with is y and z. Which two equations do you think would be easiest for me to eliminate the x?
I would say the first two, because if you multiply 2 on the second equation, it'll cancel out your x's.
That is exactly right. Excellent. Very good job. So I'm going to take those second two equations, 2x minus 4y plus 8z equals 2. And negative x minus 3y plus z equals 11. And I love your suggestion. You said if I just multiply the second equation by 2, that eliminates the x's. Beautiful plan. You are so smart. Your math teacher must be amazing. So the top equation is going to stay the same. And in the bottom equation, everything's going to get doubled. So instead of negative x, it's negative 2x. Instead of minus 3y, it's minus 6y. Instead of plus z, it's plus 2z. And instead of equals 11, it's equals 22. Very smart. Very good idea. And so now we'll just add those straight down, which has the benefit of eliminating the 2x and the minus 2x. So no x's left. That's good. That gives me minus 10y plus 10z equals 24.
What's going on?
Can you hear me now?
Yep.
Yes.
All right. Small technical difficulties. Everybody still there? Okay, good.
Yeah.
Okay, so what we've ended up with here is two equations that I highlighted in green that are both down to where they only have y and z in them. So those are going to be the two equations that I'm going to work on next. So negative 5y plus 5z equals 0, and negative 10y plus 10z equals 20. Okay. I don't care which one of these two we eliminate, whether we eliminate the y or the z. I'm really just interested in which one's going to be the easiest. What do you think?
The first one.
Okay, what can I do with the first equation to do some elimination? What would I need to multiply by?
Two.
Right, if I multiply the top one by 2, I will get a negative 10y and a positive 10z. So to make them eliminate, I need to multiply by
-2.
-2, so that I change the signs. Very good. So that makes the first equation. A -2 times a negative 5y is a positive 10y. And then my positive 5z times negative 2 is negative 10z. And then, of course, 0 times -2 is still 0, bonus. And on the bottom, the equation stays the same. All right. So now I'm just going to add these two equations. (10y minus 10y is 0. Negative 10z plus 10z, also 0. So I end up with 0 over on the left side because my y's and my z's go away. And on the right side, I have 0 plus 24, which is 24. What does that mean? 0 equals 24. Where'd all my variables go?
Oh, it means there is no solution.
Exactly right. When your variables go away and you're left with nothing, that is no solution. What would this problem have looked like if there were infinite solutions? What would we have come up with here?
It would equal 0, 0.
0 equals 0, or maybe even 24 equals 24. That would have worked as well. So this is what it looks like when there's no solution. This is kind of nice, honestly, when it's no solution, because it means you don't have to find the other two variables. So that saves you a little bit of time. So no solution is not a bad problem to have in these types of problems. All right, let's do one more of these type here. This one is going to have a solution. Spoiler alert. This one will have a solution, but it's still going to be a little weird because all of the equations aren't going to have all three variables. I'm still going to line them up like they do. We're going to be missing some variables here. All right, so give me some ideas. What do you think?
I was gonna say maybe on the third problem, if we make the 4z go on the other side, we could do substitution maybe.
You are so smart. You are exactly right. If we take this third equation here, this one, what she said was, if you add the 4z to the other side, wouldn't you be able to do substitution? And the answer is, heck yes, you could. So let's just solve that equation. That sounds like a great idea. So we'll take the y minus 4z equals -3. And what could I do here to move the 4z to the other side?
Plus 4z.
Yeah, that seems really easy, plus 4z. So I end up with y equals -3 plus 4z. You could also do 4z minus 3. That might look a little nicer. Either way is fine. Cool.
Cool.
Now what? You said we could do substitution. What kind of substitution do you want to do? Which of those other two equations do you think would be nice to substitute into?
Probably the first equation.
Right, it has to be the first equation because it's the only one with y in it. But look what's going to happen. See if you can visualize this. Let's say that I replace the y's with -3 plus 4z. So in the first equation, this y becomes -3 plus 4z. What variables is the first equation going to have? Are the first equation going to have? What variables will there be in the first equation after the substitution?
Oh, okay, so x and z's.
X and z. And what variables are in the second equation?
X and z's.
Also
so
x and z. Yeah, so that works out great. So we're going to take the first equation, the 2x plus 4y, but we're going to replace the 4 with -3 plus 4z. And then the second equation is going to stay exactly the same, 4x minus 4z. Oops, I forgot the equals on both of these. Just like that. So we've got a little bit of work to do. There's some distributive property we have to do in the first equation, but hopefully you can see that after we do the distributive property, we're down to 2 variables, which is the dream. They only have 2 variables. So real quick, we're going to distribute the first problem. So we'll have 2x plus, and then we'll do 4 times -3, which is -12, and 4 times 4z, which is a positive 16z, equals 1. And the bottom equation will stay the same. Those don't look quite like they're lined up. It looks like the first one has that extra minus 12 in it. What should we do about that?
Add over on the other side.
Yeah, great idea. So plus 12 plus 12. So that makes the first equation 2x plus 16z equals 13. And the bottom equation does not change. It is 4x minus 4z equals negative 1. Adding those equations right now is not helpful to me because nothing will eliminate when I add them. So what could I multiply top or bottom by to do some elimination?
You could multiply the top equation by 2, or negative 2.
There we go. By negative 2, what will that eliminate?
The x's.
Good. So let's multiply the top equation by 2, negative 2. So that will make the top equation become negative 4x minus 32z equals negative 26, and the bottom will stay the same, 4x minus 4z equals negative 1. And now if I were to add these two equations, something would eliminate. The x's would go away. So let's add them up. The x's are gone, as we said. So the z's then, it's going to be pretty yucky, 36z, negative 36z. And it's going to equal negative 27. Oh, that's awful. That's awful. We're going to have a fraction. See what you've done. It's all right. We're not afraid of fractions. How do we get z by itself here?
Divide negative 27 by negative 36.
Excellent idea. And we end up with z equals a negative divided by a negative is a positive. And both 27 and 36 are divisible by 9. So this will reduce from a negative 27 over negative 36 to a positive 3/4. If you're not so good at reducing fractions, if you put this into your calculator, negative 27 divided by negative 36, it'll give you the positive 3/4. It'll reduce it for you if you put it in the calculator. Okay, so good news, bad news situation here. We did solve for z, but it's a fraction. It's all right. We're not afraid of fractions. I think the next easiest one to find is going to be x, because if I were to take the z and substitute it in right there to that equation, that would tell me x, so that seems like a good idea, just to take the 3/4 and put it right in there. I also like that idea because doing 4 times 3/4 is really easy. It's really easy to multiply a fraction by its denominator. So let's do that to find x. So it'll be 4x minus 4, and we're going to substitute 3/4 in place of z. Now, if you're not super comfortable doing fractions multiplied by whole numbers, that's why you have a calculator. Feel free to multiply it that way, but it's really not too bad. Negative 4 times 3/4 is going to be negative 3. The whole number and the denominator cancel, and we're left with just the negative 3. Really not too bad. And so now we're just 2 steps away, really, from finding out the value of x. What do we need to do?
Add 3.
Add 3. Good. That gives us 4x equals 2.
Divide by 4.
Very good. Divide by 4. So we're going to get another fraction, which is not my favorite thing in the whole world, but it's not the worst thing that could happen to us. So now we have x and we have z, and the only thing left for us to find is y. So to do that, I need to find an equation that only has y in it, or not only y, but an equation that has y. If I go back up to the original 3 equations right here, I've got 2 options. I can use the first equation or I can use the last equation. Those are the 2 that have y in them. It doesn't matter which one you use. The first one has kind of larger numbers, I think. The 2 coefficient is bigger than the 1 coefficient in the bottom one, but the bottom one has a bunch of negatives. So you pick your favorite. I'm gonna go with the first one just to avoid the negatives. It's not that I dislike negatives. Negatives are cool. 2x plus 4y equals 1 was the, let me double check, make sure I copied that right. Yep. 2x plus 4y equals 1. And I know what x is. X is a half. So right here, I'm going to substitute the 1/2 that I just solved x for. Plus 4y equals 1. Now, if you need to use a calculator to do 2 multiplied by a half, you can, but don't ever tell me about it because I'll be very disappointed. 2 times a half is 1. Oh, this is going to work out so nice. What do we do next? That's right, nobody. Subtract 1. 4y equals 0. Oh, this is so nice because when I divide by 4, what do I get?
0.
0. Oh, so nice. So my solution that I came up with after all that work was x equals a half, y equals 0, and z equals 3/4. Or you can write it the way the pros do, x, comma, y, comma, z. Either one of those is a great, great answer. Who's got questions? Nobody? 3 variables is easy. You got this down? Yes? No? Maybe? Okay, so you've got an assignment this week, of course, that deals with solving with 3 variables. I will be available a whole bunch for you because I am stranded at home. I've been eliminated from showing up in person to work, so I'm going to be sitting here in front of the computer all day long checking your emails. So if you get stuck, send me an email or ask a question in Math Lab. As soon as we get done here, I'm going to upload this video and then put a link to it in Blackboard, and I'll also make a PDF of the notes that we just did and put those in Blackboard so that if you want to go over and review it again later, you can. And then in your Math Lab, you've got not only this assignment, but you also have the Unit 4 test, which covers solving systems. I'm going to give you a, let's say, generous due date on those just because of how crazy the universe has become. So they're not going to be due before class next week. I'll give you a couple of weeks to get them done. And then next week in class, we're going to work on doing exponents and polynomials. And that's the last unit of this class is exponents and polynomials. So the end is near. We'll have, looks like 4 classes after this one, and then we'll be ready for our final. So hopefully the world makes a little more sense by then and we're able to actually see each other in person. But if not, I'll keep doing this. Any questions for me about anything? Last call?
Nope.
All right.
Nope.
Y'all stay home and stay safe, please. Talk to you later. Bye.
Thank you.
Bye.